So, today I want to start by telling you a story about Anna. She's a sweet older lady who has kids and grandkids. She lives alone in her cozy apartment, and every Sunday her family visits her and Anna prepares Sunday meal for them. Her favorite dish to make is her famous Black Forest cake. She goes to the supermarket the day before to buy the ingredients for the cake, and she made it so many times she doesn't even need to write down the shopping list for it. So she picks up flour, chocolate, milk, and then she pauses and she realizes she cannot remember the next ingredient. She can't even remember where she is, how she got here, why is she here. This is a very terrifying experience. She feels scared, lost, alone, standing in the middle of the store, completely helpless. This experience is way too common for people who suffer from Alzheimer's disease. And unfortunately, 1 of 10 people is expected to get dementia as they grow old. Alzheimer's doesn't just steal your memories, it changes who you are. It affects judgment, it causes depression, anxiety, and might even lead to hallucinations and delusions. So, what causes such a devastating condition? We don't know yet, but many scientists all over the world are working really hard on figuring this out. What we know for sure is that in the brains of patients who suffer from Alzheimer's disease, we can find one thing in common: protein aggregates, these clumps of misfolded proteins. So, what are those proteins? Proteins is our helpers. They have so many different functions. Some of them are building blocks for our body and our support system. Others help to digest our meals. Other proteins protect us from infections or move the materials around our body. But proteins need to have a specific complex structure in order to function properly. In biology, shape, structure, function usually go hand in hand. So the chemical composition of a protein makes its ability to function properly. And if protein loses this complex structure, it cannot function anymore. And this is what happens during protein aggregation. So I have an analogy to help to explain this process to you. Nowadays, we use our AirPods, which is very convenient, but back in the day, we were using wired headphones. When our headphones are entangled, we can listen to the music, we can enjoy it, and then when we don't need them, we throw them in our bag. After a hard day at work, we are going home and we want to listen to some music on the U-Bahn to relax. And then we rummage through our bag looking for our headphones. And when we pull them out, they are a tangled mess. We cannot easily untangle them. And while they are knotted up, they are completely useless to us. We cannot listen to our music, we cannot relax. And the same thing is happening to proteins in our body. So when the proteins are tangled up, they cannot perform their functions, and they can even interfere with the functioning of other proteins. So in Alzheimer's disease, one of the proteins that get tangled up and stop functioning properly is called tau. What does this protein do normally? So here you can see in green main cells of our brain, neurons. And tau is very important for supporting the structure of the cells. So it acts like a scaffolding protein. It maintains the structure of the neuron and allows the material to be transported through it by other transport proteins. In Alzheimer's, tau is in big trouble. It gets tagged by chemical tags, and this makes it more prone to lose the correct shape, to misfold. And these misfolded proteins are very sticky. They stung to each other, they form clumps, and then they have this really nasty feature. They infect normal proteins and make them tangle up as well. So the clumps grow bigger, bigger, they aggregate like a snowball effect. And then the aggregates in the brain are being formed. Those tau aggregates accumulate inside neuronal cells, and then neurons lose their support structure. So the scaffold of the neuron is ruined, tau is messed up, neurons cannot get the correct materials transported, it cannot perform its functions properly, and then it dies. This is how those tau aggregates look inside neuronal cells, and it might look like a piece of abstract art, but unfortunately in the brain it doesn't look that beautiful. It's actually quite deadly for the cells. What I'm doing in my project, I'm trying to figure out how we can influence this aggregation of tau. How can we make it better or worse? What is a factor in play? So if we throw in our bag not only our headphones, but also our charging cable for the laptop, for our phone, all of this gets messed up way too quickly and much stronger. So these are factors that make aggregation of tau much worse. However, if we are smart, not like me, because my bag is always messy, we buy the cables organizers, and this can prevent tau from forming those clumps. So in my project, I'm looking at another protein, which is called ApoE, and I'm trying to figure out how it influences tau aggregation. So I think that ApoE makes it worse, and it acts like another charging cable that is thrown into your bag and gets entangled with tau. Then this mess is really hard to clean up. So by understanding what can influence aggregation of proteins or what can stop it, we can prevent Alzheimer's disease from progressing, and maybe one day less people like Anna will feel alone and confused in the supermarkets. Thank you.
Taisiia Nazarenko from Synergy.